Hi, my name's Betty Gomez, and today we're going to be finding the vapor pressure using Raoult's law. So bromine is sometimes used as a solution in tetrachloramate, also known as carbon tetrachloride. What is the vapor pressure in torr of a solution of 1.5 grams of bromine in 145 grams of CCl4 at 300 K? The vapor pressure of bromine at 300 K is 30.5 kilopascals, and the vapor pressure of carbon tetrachloride is 16.5 kilopascals. So how can we approach this? We can use Raoult's law to find our total pressure. Raoult's law says that the total pressure is equal to mole fraction of A times the pressure of A plus the mole fraction of B times the pressure of B. To find our mole fraction, we can just divide the mole of A over the mole of A plus the mole of B. To find our pressure, we just need to make sure that we convert it into torr. So in our problem, they give us a number of things. They give us the mass of bromine, which is 1.5 grams, and the mass of carbon tetrachloride, which is 145.0 grams. They also give us the vapor pressure of bromine, which is 30.5 kilopascals, and the vapor pressure of CCl4, which is 16.5 kilopascals. So our first step would be to convert our mass into moles. We know that bromine is a diatomic element, so we would multiply its molar mass by 2. We have 1.5 grams of bromine, so we divide that by its molar mass times 2, which is 159.81, and we find that our moles is equal to 0.009386 moles. For our moles of carbon tetrachloride, we have 145 grams, and we divide it by the molar mass, which is 153.82 grams, and we find that the moles we get is 0.9426. So now that we have our moles of bromine and we have our moles of CCl4, we can find our mole fraction. So our mole fraction of bromine would just be the moles of bromine divided by the moles of bromine plus the moles of CCl4. We found that our moles of bromine was 0.009386, and our moles of CCl4 were 0.9426. So from there, we can find our mole fraction to get 0.0986, and this is approximately 0.01. To find the moles of CCl4, we would use the same method, so our moles of CCl4 over the moles of CCl4 plus the moles of bromine. From there, we find that our mole fraction of CCl4 is 0.99. For step 3, we would need to convert our pressure into torr. So we are given our pressure in kilopascals, and we know that 1 kilopascal is equal to 7.506 torr. So to convert our pressure, we can multiply our kilopascals by 7.5006 torr to get our answer in torr. So for the pressure of bromine is just 30.5 kilopascals times 7.5006 torr, and we find that our pressure of bromine is 228.7 torr. We can do the same thing for CCl4 and get our pressure to be 123.7 torr. So now that we have all parts of Raoult's law, we can plug it in and find our total pressure. So we found that our mole fraction of bromine was 0.01. We found that the pressure of bromine was 228.7 torr, and we can add that to CCl4's mole fraction of 0.99 multiplied by its pressure of 123.7 torr. When we add it all together, we find that our total vapor pressure is 124.75 torr. To the correct number of significant figures, which is 3, we find that our total vapor pressure is 125 torr. So in this problem, we found our mole fraction, and we converted our pressure into torr, and we plugged all of this into our Raoult's law, and we got our total vapor pressure to be 125 torr.